Hi guys, this is a tutorial of how to run a Pearson's chi-square test or chi-square test of association using two different types of data sets, both using raw data like this one here and using frequency tables. Okay, so for chi-square tests we usually use relatively simple data and they should be categorical. And in this case we have from 13 people eye colors, green, blue and dark, as well as their sex. So each person in this kind of raw data set is represented by one row of data, and the information we know about that person, those different variables, are in the columns. If we go to our variable view, we can see that there are three types of eye color and there are two types of sex here. Both of these are nominal variables because they are categorical and there is no hierarchy between them. And if we go back to our data view, we can toggle between label and category. That's one way of setting up this data. In this case, we have 13 people, so there's 13 rows of data. But let's say you had 130 or 1,300 people for which you have collected this kind of data, then creating a data set with 1,300 rows would be quite tedious. And one other way of setting up data for this kind of situation when you have categories is to do it in a frequency table, and I've done that here. So essentially this shows exactly the same thing. These frequencies here add up to 13, but instead of having one row per person, I now have the different categories of eye color and the different categories of sex, and I have made all of the possible combinations between those. So for example, because there are three eye colors, two sexes, I now have for each eye color, I have how many times that occurred in females. So females with green eyes, females with blue eyes, females with dark eyes. And then the same for the males, males with green eyes and so on. And then here I have given the frequencies of those. Okay. Now, when it comes to how we can analyze this kind of data, and I can show you quickly what this looks like in your variable view as well. So we have two nominal variables, eye color and sex. Okay, it's just like before. They're all set up with three different categories: 1, 2, and 3 for the eye colors, and 1 and 2 for male and female. Okay, and we can toggle between label and value just like before. Okay, this is the way that you set this kind of data set up if you want to use a frequency table. And that would look exactly the same if you had 1,300 people, you just have higher numbers here. Okay, frequency is a number, obviously, so that has to be set up as scale. Now, what we might be interested in with this kind of data, and I'll show you first on the raw data, is whether it is more likely that if you are a female that you have one of these eye colors than the others. Okay, so within females or within males, is one of these eye colors more common than the others? And that is essentially looking for an association between the sex of the person and their eye color. Okay, that is called a chi-square test of association, or Pearson's chi-squared. And if we want to find something like that out, and this could be different things, so we could, for example, have here people's opinion on one thing and on another thing, and we could see whether people who have one opinion in one situation also have a certain opinion in another on another question. So questionnaires are usually where we get this kind of categorical data. So in this case, we're interested in whether being a female makes it more likely for you to have green eyes or blue eyes or dark eyes, or being a male makes it more likely for you to have one of these eye colors. Okay. In order to run this test from the raw data, we go into Analyze, Descriptive Statistics, Crosstabs. And here we essentially have, this is the window that pops up. Now, into the rows and columns go those two variables, and which way around does not matter. So you can just put one in the columns and one in the rows. It basically will just associate these with each other, and which way around you place these doesn't matter. Okay. Then we have to make sure that SPSS know we want to run a chi-square test on this. Okay, so we need to tick this. And we also want to make sure that chi-square doesn't only tell us what we've observed, so how many times did each of these occur, but also what we would expect if the distribution of these different categories were due to chance. And that is what we are comparing here. Okay, so basically we're looking at what we've observed, how many females have green eyes, blue eyes, etc., and how many males, versus the case that we would expect if there was no association between these two things, if they were completely independent of each other, and what we observe here was due to chance alone. That is what the expected tells us, and it's calculated with a very simple formula that you would have been introduced to in the lecture. So we just make sure that it shows us both because it's quite interesting to look at. And then the other thing we can do is we can get SPSS to throw us out a clustered bar chart straight away as well, because that's just quite good to see and get an overview of the data. So then we just press OK, and in our output table, as always, we get the output of this test. And this is what we have here. Okay, so this is just a quick overview. We know we have 13 individuals. This is our cross tabulation that we have requested. And in addition to telling us what our counts were, okay, so how many people with green eyes, we have 3 males, 3 females, 1 male, a total of 4. How many people with blue eyes? No females, 3 males, that's a total of 3, and so on. It also shows you our expected. And this is what we would expect if there was no association between these two variables. And the chi-square test essentially compares these two situations to each other. And then this is our chi-square test result down here. We're interested in this top one. We have our test statistics, our chi-squared value, our degrees of freedom. This would have been explained to you previously, and importantly right here we have the p-value. Now in this case the p-value is over 0.05, it's 0.99, and that means that we accept the null hypothesis, and the null hypothesis always says that there is no link, no difference, no association in this case between people's eye color and their sex. Okay, so because someone is female doesn't make it more likely for them to have green eyes, blue eyes, or dark eyes, and being male also doesn't make it more likely to have a specific eye color. Even though we might think so from what we see here, for example, we could say that the mode here for females with dark eyes or for dark eyes is 4, and that's in the females, but it is not significantly higher than the number of males with dark eyes. Okay, so that is our test result here, and this tells us that there is no association between eye color and sex in our 13 subjects here. This is our clustered bar chart that we get. Okay, it shows us for males and females in blue and green what the different sort of frequency counts were. So how many times did each of these occur? It's essentially the same as this table up here, but in a graph. Okay. Now, as I said before, we can do exactly the same thing using a frequency table, because if this was 1,300 people, then creating a data set like this would be quite tedious. And that's very simple. If we have this kind of frequency table here, we just have to put one additional step in there before we run the test, and that is to weight these cases with the frequencies. So essentially linking these numbers, these frequencies, how many times each of those occurred, to these categories. Okay, at the moment they are not linked, they're just separate variables. SPSS doesn't know that these have anything to do with each other in terms of what SPSS is concerned. Actually, this is a separate variable altogether, which it actually isn't. This tells us how many times each of these category combinations occurred in the data set. And we just need to link those two things together. And that is done in data, weight cases, and then I've done this before, so normally what the situation you would find, I'll just reset it to the default. This is what it would look like in default. Usually it hasn't got weighted cases, but in this case we do want to weight the cases. We want to let SPSS know how many times each of these combinations occurred, and we use our frequency variable for that. So we just shove that over here and then press OK. And now SPSS knows how many times each of these combinations occurred. And we can do the test exactly the same way that we did before. Descriptive statistics, cross tabs, and we put our eye color and our sex into the rows and columns. Doesn't matter which way round. We just select chi-square here, and we make sure that we get shown the expected frequencies as well as the observed. Press continue. We're going to get a clustered bar chart again, just in case. And we press OK. And the result that we get is exactly the same as before. okay? Because those two data sets are exactly similar, exactly the same. It's just that in one you have 13 rows of data for each person, and in the other you have summarized the data in a frequency table. Okay, and if you watch the other chi-squared video, it then shows you how to run chi-squared tests when we're just interested in the distribution of one variable and not an association between two. Now, one last thing that is interesting here, or that is important to note, is that there is a warning associated with this chi-square test output, which is down here. It says that 6 cells have expected counts less than 5. Okay, now this is a problem because essentially the expected count is calculated using what you've observed. Essentially, there's a very simple calculation using the totals of the rows and the columns. And if there is not enough data here, because in this case we only have 13 people, then it can be that the expected in these cells is less than 5. If that's the case, then essentially the test is not very reliable because it basically says, I haven't got enough data to base this comparison on. Okay. Now the only way you can get around this problem of this test not being very reliable is to increase the sample size. So when you get an output like this and you get this kind of warning underneath, then essentially you have to go back and think about getting some more samples because this isn't a very reliable result. Okay, so you would then have to go and actually just ask some more people about their eye color and look at whether they were male or female. Okay.